Let's just run through a few examples of how action selectors can influence method selection. I have a simple project open that has a few action methods on our home controller. I've created a fairly common scenario where two methods have the same name, but they accept different parameters. This type of setup is often used to retrieve and then submit a form that users can fill out. Well, if we run the solution right now, let's see what happens. So all we get is an error page because the action invoker doesn't have enough information to make a good decision. We can fix this with action selectors. So let's jump back over to our project and do that. You may already be familiar with the HTTP GET and POST selectors. If we assign HTTP GET to the first method, it will be given priority over the second method for a GET request, even if both could theoretically service the request. By explicitly stating that we want one of them to handle GET requests, that method will become prioritized for GET requests. So I'll just add that attribute on top of this method, and if we rerun our project, our first method should be chosen. So our page loads just fine, meaning our attribute provided enough information for the action invoker to make a good decision. Now back in Visual Studio, keep in mind that if we were to also add the GET attribute to the second method, we would be back in the same spot as before. If you remember from the slides, we can also get into trouble using action selectors if all of them resolve false, and there's no fallback method to choose from. So for example, if I decorate both of these methods with the post attribute, that will cause an error as well. With both of those in place, if we rerun the project, we should see a familiar problem. So this is all pretty straightforward and familiar, but there are a couple of other important points I want to make. The first is that you can write your own logic to influence action method selection. We can do this by writing custom action selectors. Let's jump back over to Visual Studio again and see how this works. Writing your own selector is surprisingly simple. Let's just right-click on our project and choose to add a new folder, which we can call Extensions. And inside this folder, let's right-click and add a new class. In the dialog box, we can give it a name of isMobile and then choose OK. After that class is created, we want to make sure that it inherits from a class called ActionMethodSelectorAttribute. This class has an important method we can override called isValidForRequest, like we discussed in the slides. This method simply returns true or false. If it returns false, the associated action method will no longer be a candidate to handle the request. So this custom action selector will choose methods based on whether the request originated from a mobile device or not. ASP.NET offers a useful property on the request object that states whether the current request is from a mobile device. It's not 100% accurate, and in a real project you may want to use a more reliable way of determining this, but it will work fine for our purposes. So we can just type return controllercontext.http context.request.browser.isMobileDevice. Let's jump back over to our controller now and put this into action. So we have our two action methods right here, and let's just quickly delete the existing selectors that we applied to them. So I'll just take care of both of those real quick. And now let's attach our isMobile action selector to the first method. Let's also change the return type of this method to a JSON result. Let's assume that if the call comes from a mobile device, it simply wants data in a JSON format because the app handles its own UI and presentation layer. I'll just add in a JSON snippet here with a simple key of message and a value of display on mobile devices. Now if the request comes from a desktop, this method will be skipped as a selection candidate and our other method will handle the request. On desktop, we want to return a full MVC view to render the results. This might not be how you'd want to structure device-based responses in a real project, but I think it works for our simple example. There's one other idea I want to reiterate here. Since our two action methods have different return types, our action selector can actually impact the MVC request lifecycle in a pretty big way. In cases where we return the JSON result, a view engine will not be needed to render the response that will be sent back. However, if we return the view, it will be used. So our action selector may or may not remove one of the main components of the MVC pipeline for a given request. Let's add a few breakpoints before we run our application. I'll add one in each of these controller methods, and then we can jump back over to our selector class, and let's add one inside of our method here too. We can now run our application to prove that this is all working. So right away we hit the breakpoint in our action selector. Notice how this is happening before we hit any action methods. Our action invoker is deciding which method to choose, so it executes our selector to gain more information. In this case, our filter actually returns false since our request came from a desktop. This automatically disqualifies our method as a candidate. If we hit continue, you can see we jump into the desktop action method and the other one is never hit. We can continue out to the browser to see how this renders out. So the view for our desktop action method renders just like we'd expect. There aren't any surprises here, but that's a good thing. We want to make sure our action methods are selected in a predictable way every time. We can adjust and customize that process as necessary using custom action selectors.